Hello students, myself Vikas Tiwari. Once again I welcome you to my channel Map World of Physics. Okay, and if you want to download from our application, you can download from Play Store named Mass Academy Advanced Physics. So we are dealing here with the concepts of circuit analysis. In my previous lecture, just I have told you about what are the basic 8 things or basic 8 tools just to study the circuit. In that context, I have given you the list of the that 10 particular tools as first one is KVL, okay, second one is KCL, okay, and third one is nodal analysis, nodal analysis, okay, and the next tool is mesh analysis, mesh analysis. Next one is voltage division theorem, voltage division theorem, and next is current division theorem, current division theorem. Okay, then concepts of open circuit and short circuit, concept of open circuit and short circuit. Okay, so concept of open circuit and short circuit, and finally source transformation. What are the concepts of source transformation? Okay, so let us, I have already discussed about the KVL in my previous lecture. Okay, so now I am going to take today what is KCL. Okay, so in that context, just I will be going with the concepts of KCL. KCL stands for Kirchhoff's current law. Okay, Kirchhoff's current law. In this Kirchhoff's current law, if we will go for the statement part is very clear, and it is like that: at any node or junction, at any node or junction, algebraic sum, algebraic sum of all the currents is equal to 0. And if we are going to represent it mathematically we can say summation of I is equal to 0. Okay, so this is the basic statement, is very simple, and its mathematical representation is also simple. Let us go for its application part. Okay, just before going to the application part, just I want to say I want to differentiate between the word node or junction, whether these two words are same or they have some difference. Okay, so let us discuss. First I will go with the concept with the node. What is node? Okay, so node is defined as where two or more than two elements meet. Okay, so what are the elements that I have told in my previous lecture, and that is elements. What are the elements in circuit? These are the elements named as R, resistor, inductor, capacitor, voltage source, current source. Okay, so these all are the elements over here. So what I have written here, where two or more than two elements meet, that point is called node. And then what is junction? Junction is somewhat where current divides, where current divides. Okay, so let us elaborate it more. Just I am taking one example. Okay, if I'll say, just I am making a simple circuit here. Okay, Okay, here are some resistors. I am using R1, R2, R3, R4 randomly I am taking. This is voltage V1, this is voltage V2. So just I am telling you what is the difference between node and junction in this circuit. Okay, what I have told you, there is always a node that is called reference or ground node. Okay, in any circuit you will find reference or ground node which is required to give the return part to the current. Okay, so the circuit won't complete without reference node, and the current will not return back to the source without any reference node. So this is what we call reference node. These are the reference nodes. These are not different nodes, but these are same points that I have already told you in previous lecture. These are equipotential points, so therefore their potential difference is zero. Equipotential means the potential of each point is same. Okay, then what we say, potential difference between these 2 points, 0, potential difference between these 2 points, 0, potential difference between these 2 points, 0. So we can say these are not different points, these are considered as single node. Okay, so this is what we called reference or ground node. This is called ground or reference node. Okay, every circuit will have a reference or ground node, as without any ground or reference node there is no return of the current cannot be returned to its original source. Okay, so this is always a ground, but we won't count it in the counting of node or junctions. Okay, so it is just separated from that particular counting of node and junction. Okay, so now I will say this is one elements I have already mentioned you over here. Okay, so this is one element, this is one element, so I will say this is a node, this is a node. Okay, 1 2 3, two or more than two elements, okay, so this is also a node. Okay, 3 elements, this is also a node. Okay, and these are 2 elements, this is also a node. Okay, so these are the nodes. So we can say 1 2 3 4, so we can say 1 2 3 4, these are considered as nodes, And then what are junctions? So let us say I will take a randomly, I will take a current which is starting from this source. So I will say this is current I. Okay, this current I will reach over here and it will divide at this particular points in I1 and I2. Okay, further the I2 current will reach here and it again divides in the current I3 and I4. Okay, so in this branch there is no division, so we will say I4 in this current in this particular branch, and what will be the current in this particular branch, that is I. But the current is dividing here I1 and I2. I current is dividing in I1 and I2, and I2 current is dividing into I3 and I4. So I will say that 2 and 3 points are considered as junction. Okay, so these are considered as junction. So we can say that junctions can be considered as node. Junctions are node, but not all nodes are junction. Okay, not necessarily that all nodes are junction, but junctions can be considered as node. So that's why I have written the word here as node or junction, means I am considering node or junction. But the important particular point is that nodal analysis is applicable on junctions. Okay, so we will apply, mostly we will apply on junctions only. Okay, so that is the particular difference between node and junction. So what I am saying, so first I have elaborated the difference between node and junction over here. Okay, so let us come back to our important point. At any node or junction, algebraic sum of all the currents is equal to 0. Okay, so statement is very simple, but let us go with the application part. Okay, so what we will say, what is the sign convention basically we are using? Sign convention, what is basically the sign convention we are using? Sign convention is that, okay, so if for that I am just taking an example. Okay, suppose this is some node over here, node or junction over here. Some currents are outgoing from here, I1, some currents are incoming. Okay, some currents are outgoing, this is I2, this is I3, and some currents are incoming. Okay, some currents again are outgoing. Okay, some currents are again outgoing I5 and some currents are again, I'll say, I6. Okay, so this is incoming current. Okay, so in this particular, at this particular node or junction, some currents are coming and some currents are going. You can see over here, at every junction there are some currents which are coming and some currents are going outwards from the junction. This is incoming to the node junction, or this is outgoing from junction. Okay, so direction is considered as outgoing. This is the direction considered as outgoing. This is the direction considered as incoming direction. So what I'll say that there are some currents which are, so let us identify some currents which are in one direction, I1, I3, I1, I3, I5. Okay, so these are one direction of current. Okay, these are outgoing currents. Okay, and then I will say out I2, I4 and I6. These are incoming currents. Okay, so what is the sign convention? Sign convention says, it all depends on us. If I'll say that all the outgoing currents are taken as positive, in that particular current, in that particular case, all incoming currents are taking as negative. So this is one rule set. Also you can follow, you can also take it like this: if outgoing currents are taken negative, then incoming currents are taken as positive. But make sure you can't mix these two rules. You have to just follow one rule. Throughout my lectures I will follow this particular rule, in which outgoing currents I will take as positive and incoming currents I will take as negative. Again I am telling you, you can also follow this particular thing, but make sure you have to follow one of these two things. Okay, so if I'll say what is the current over here, if I will say summation of all the currents is equal to 0 at any node or junction, summation of all the currents is equal to 0. So here I will take, what will be the value? If I will follow this sign convention, I will take I1 as positive. Okay, plus then I will take I2 as negative. Okay, plus then I will take I3 as positive, plus then I will take I4 as negative, plus then I will take I5 as positive. Okay, and finally I will take I6 as negative, and summation of all the currents is equal to 0. So this is only one line application of KCL. Okay, so this is only one line application. Other than that, for calculation you can write it I1 minus I2 plus I3 minus I4 plus I5 minus I6 is equal to 0, or I1 plus I3 plus I5 is equal to I2 plus I4 plus I6 is equal to 0. So this is what we call summation of outgoing current. ठीक है, summation of outgoing current, and this is equal to summation of incoming current. So what is another form of KCL or KVL, or another definition? Sum of all the incoming currents and outgoing currents at any junction are equal. Okay, so all the outgoing currents is equal to all the incoming currents. So this is what we called KCL. Okay, so this is the elaboration of KCL. KVL I have already elaborate you. So this is what we are going to use further in the application part of our concept. I hope it made the clear to you what is the basics of Kirchhoff current law. Okay, thank you very much.